friends. Welcome to another episode of Build-Run.com, Build and Run. This is a VR podcast for Unity developers. We're here at NYC VR University. Full house, packed house. Everybody has viewers, everybody has smiles. And we're here to hear Callewaert give us some knowledge. Thank you.
Awesome, blah, blah, blah. Those are words who are not measurable, so who cares about that? Okay. Let's see if can the projector work here.
Oh, it's HDMI right here on the side. Let's go. It's good. Just one. Go ahead. Yeah.
Is it two or one?
Yes, that's it, yes.
Okay. My presentation is you don't. Oh, okay. Is Stacy here? Okay, can I use this? Okay. Hello, 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 hello. Because I prefer to walk. Okay. Hello, 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 hello.
I'm not an easy person, so this is like...
You're not a technical person? Hey, look at that.
It's working. Hey, Stacy!
Okay. It's really loud, eh?
You can turn it down here.
What's that?
That's good. You can turn it down.
Not bad.
Because I'm afraid from the microphones when I walk. Okay. Does that work for everybody?
Yes.
Okay. So, before I continue, who has already worked with VR like on Google or Oculus or HoloLens? Raise your hand. Okay. Who's a programmer here? Okay. Wow, what's going on? Programmers versus what? Who's an artist? Okay. Who's a designer? Okay. And who's an architect? Okay. 1, 2, okay. 3. So, did they actually build something? Okay, I didn't. I took all the courses, and after 3 weeks working in marketing, I'm never doing this. Okay. But this is what I want to come to. I think my title is Build Architectural and Gaming Environments that Create Presence in AR and VR. Presence is a really buzzword right now. It's, hey, do you connect with the environment? Are you absorbed in it? But if you build, and actually the title of my presentation would have been Hingus Loci for Room Scale VR AR. If you're an architect, you might know the term Hingus Loci. No? Let me explain it then. So when you build room scale VR or room scale AR, it doesn't matter what it is, you want to basically an architect. Because you're building 3D environments that are real to the size for you. So basically you're an architect. And you want to create, you're wondering, how can I create nice buildings? How can I make sure when I put the HoloLens on, and I put, say, a visualization in there where I explain certain objects like a pillar or something, or construction, how do I really absorb for that? How do I feel one with that object networks? Okay, and now what we call is, so you want to create architectural presence, the connection with the environment, they understand it. Okay, everybody's so quiet. Okay. So you might be wondering, hey, how can the internet help me? If you're not an architect, you start to Google, hey, what is a nice building, what's nice shapes, what's nice proportions. Okay. So after this presentation, you should have a better understanding and techniques that you can use to really bring out the stereoscopy, the 3D aspect. We're going to talk more about that. Explain how you can see and how you see. There's a lot of, not this. In terms of that, we assume because we have 2 eyes. That's it. A lot of times we see it. That's what we think, okay, we have a HoloLens because it has 2 projections. It's now in 3D, instead of stereoscopic. And also we're going to have a little bit fun fact, what is alive and true on the internet versus object presence. Now presence, what we think is a modern word. No, it's totally not modern. It comes back from a long time ago. Even the Egyptians and the Romans knew that. And they call it Hingus Loci. Hingus Loci means, anybody studies Latin? Nobody? It's obligated that when I was a kid, 6 years studied Latin school.
We're American, we don't do that.
What's that?
We don't do multi-language in America.
Hello? Okay. So English Loci means the spirit of the environment, literally. It used to mean, it came from the word, the defender of the environment or the building. Okay. Now if you think about that, when you place you back in the time of Romans, and you went to a temple, or the Greek, or the Egyptians, they felt as a sacred place. They were magical, really in contact with the building and understanding, hey, how that skills works. And we're going to talk about how they achieved that so that you understand how you can do it in VR or in AR. During this presentation, I will be using a lot of real examples. Why? Because there's not much yet examples in AR and VR that really stand out. And that's why we're going to use real examples, because there's no differences if something is real or virtual or augmented reality for my eye. For my eye is just an input sensor to my brain to make it 3D in my brain. There's nothing much to it. So we will be talking about, anybody knows this building?
Pantheon.
Pantheon. Fantastic. Been there?
Yes.
Okay. When you walk inside, you're stunned by the dome they created. 33 meters, it was the largest expansion at that time. And they created it. That's why Microsoft used that as one of the first examples in the HoloLens. This be produced. You knew that, Stacy? Okay, we're going to talk why. What's the name of the opening? Oculus. Who said it? Okay, yeah, it's called the Oculus, not DK2. Okay. There's a lot of, when you're going to type about beautiful buildings, you're going to run into Notre Dame. Is it true or not? And we're going to see that. When you stand in front of this building, why does captivate us so? And why this architect? Anybody knows this architect? Yeah, Tarawando, super known architect for light. How he understands that light and reflection works in our eyes. If you don't know this yet, then you skipped and probably high school too. Is it beautiful? Some internet says it's because it's really beautiful and the shapes and everything. For me, it's a pile of rocks. I've been there. So. Anybody knows this square?
Yes. St. Peter's.
St. Peter's Square. And to disclose, we're going to do there's a presentation we will learn. This is actually the basic of game design. You will see how it's connected with VR and AR too. So what we actually want to discuss is there a science, is there a language that we can use to create beauty? Is there a language of architecture? And when you read on the internet, there's a lot written about that. And historical books a lot. Right? So what we want to understand is how to create English Loci. How can we create an environment that we can connect and understand in the spirit of the environment? But before we understand that, we have to understand one thing. How do we see 3D? If you understand what we see, then you can use it. Okay. There's three parts we have to discuss to understand how we see 3D. And in those three categories are a lot of sub-branches that I cannot all cover. Okay. You might be wondering why the learning is all. I took a course a long time ago when I was handsome, beautiful, and strong on how we see 3D. Okay. No, part one. So because we have two ones. Okay. And there's a few things about that. One, our eyes are more than 550 million years like that. It didn't change really. So you're not going to change very fast the behavior of what we see and have depth perception with our eyes. And we cannot move our eye. It's really simple. Now, our eyes is the stereopsy. And what it means in Greek. You didn't study Greek in school? I only did 4 years in Belgium when I was a kid. Okay. It means a solid shape. Now you really understand the shape of it. It's how you actually perceive something 3D. You have to understand that actually you see two images, we only see one. Okay, you see left eye and right eye, and that becomes one. But you cannot distinguish between left and right. You have to close your eye. So that's depth perception. And a lot of animals have the opposite, and it's depth sensation. They don't have that. We don't actually see what they actually see like us. So that's why we call it depth sensation. Right? Some animals don't have a huge overlapping area. And we're going to see how actually that works with animals, how they see. Now what we know as humans that we have two different images that we see in our brain, and it becomes one. That's depth perception, that it becomes one image. It's a left eye and a right eye, and we have about 3 inches between our eyes. Okay. Now it's a left eye and a right eye, and a little bit different. Okay. What if you notice on the HoloLens something totally different? He's shown on the left eye a dog, and on the left eye a cat. What is going to happen with you? You're gonna get really dizzy and sick. No, in Unity there's an API that you can actually say render the left eye and the right eye totally different. In which case would you use that?
A gun?
Yeah. It's the only way. Pirate game or a sniper game. Because you close your one eye. If you would show something totally different, I can guarantee you, Stacy will be really dizzy. Okay. No. Our eyes are still adaptable. Anybody knows an experience? Yeah, you see upside down. It's in the early 1800s, an experiment done where you actually put the glass on and see upside down, but very fast you're able to drive, you're able to eat, and then you take it off again. And that's a nice example that we are very adaptable to it still. Yeah, like here, nice the game from Atlas, where you fall down, you actually, the rotation of your head is accelerated. When you rotate 45 degrees, you look already 90 degrees down the game. And you see that also with certain objects in VR, when you walk closer to it, it comes faster to you. You still very fast adapt to those elements. Okay. No, this is more interesting. There's another part, obviously. We perceive the space. Because we have 2 eyes and we have also 1 eye. We have a lot of molecular input in our seeing. Not because you have 2 eyes. 2 eyes is only, I'm not going to go into it, but there's only 3 elements why we have actually C3D. And can we build in the space because C3D? But there's a whole list of elements of 1 eye that help us to understand the space. If you understand those, and you can bring it out in VR, 1 eye will feed you 2 eyes. Now, some things we are born with. I'm not going to go all in detail, but like one of the things we are born, and that's why the HoloLens works, you're born with the ability that an object is in front of you, that you can distinguish between the environment and the object, and you grab that. That's why the HoloLens, we don't have to teach you, this object stands for the environment. It's really born with that. Well, there's a lot of things that you're not born with, and that you learn over time. And the little kid, when it's born, sees upside down, they don't know exactly what the procedure happens, I'm not going to go into that. But you still are learning, and for the rest of your life, you learn to see. You learn to understand the depth and the perception. Now, example is this. One rock is 40,000 kilometers further from each other. You don't know, if you don't know the shape, how can you understand the space? When I hear, I'm going to create AR and VR of a new world that nobody's seen before, good luck. Okay. We know because familiar sights, and it helps us to understand the space. We know this picture is fake because you know the size. If you don't know even the size, you know the granularity of the rock. That will you understand. And I'll talk later about that in bad examples. This is an image. You perceive it or see that 3D. If it's no 1 eye or 2 eyes, it doesn't matter in this case. You can close 1 eye and you're going to see the same. Agree? And it's quiet here. No. One of those molecular aspects, the molecules we usually have from my 1 eye is the familiar size. I know the size of the stop sign. I know the sign of the car. Because of that, I can build up my space. That's why in VR, use objects, or in AR, you know. If you never know, how can you understand it? Okay? I'm going to come back to that also. So, there's a lot of aspects here that help me understand. Like the granular texture, like the grass. Sometimes I see in a VR game or an AR game, and they put a patch of grass with the wrong scaling of the texture. What is the brain saying? It doesn't work. And on one side I'm saying it's grass, on the other hand I'm saying it doesn't look like grass. So you CPU's overdrive. Okay? It's the same with the flowers. But also we have aerial perspective. And that means the varying of the color when an object goes further, it blends more in the background because we have less color contrast when objects goes further. That's why the back, we can understand if an object is that color, that far, we understand that. So those are input on your one eye that feeds you two eyes. In Unity examples, we use that a little bit. And like here in this AR game, we use a human being there to give you some clue on how big the environment is. If you don't know what the size of an object is, you will never be able to get the presence, the connections. Is it boring?
No. Great. Awesome.
Okay. No, this was another example done by Unity where you shoot, I don't know what it is. Targets, yeah. Well, if you have it like this, you never have a built connection with the environment. You're never going to enjoy it. Because you cannot feel the space. You don't understand the depth. If you don't know how far it is, how can you connect with it? And that's why add elements to it that you know that you can build the size. Of course, I still find a bad example. One of the things that you also understand 3D is because horizontal expansion on the retina. That means when you see an object, and it has a certain percentage on your retina, when it goes close or closer, and it's a familiar object, you will better understand the depth. Okay. That's why in an example I would have to put those targets right next to me, so I have a better size next to a familiar size. And then I would throw those targets away in the scene, and then your eye can very fast understand how far it is. Okay, you have to watch out. This is a process you learn. This is something you're not born with. You can see kids when they play football. So how long does it take, on average it take from board until you have a very good perception of depth, using all those molecular inputs?
Seconds. Less than a second.
No, how long it takes to understand, to learn it all?
Oh,
3 years? 1 year? 8 years? Have you seen kids at 8 years play football? What happens with them? They hit their head, they go like that. It's because they're still learning. It takes on average 13 years to have a very good depth perception and hand-eye coordination. That's why kids in the 13 with VR will be more difficult, because they're still learning. Okay. Now we have here this example. Again, there's other elements why we see 3D. Then we perceive it as 3D. And we can learn that. It's perspective. That's also one of the molecular inputs in our eye that helps us understand. If you don't use those elements in AR or VR, how can you build up your space? Okay. Masters of the light, they totally understood that. Use known objects with perspective. Really build up that space to understand what's 3D. Okay. We have to watch out with perspective. What do you see? Cube. Because you learn to see it as a cube. You learn to see perspective. Not everybody will see it as a cube. So native tribes, depending on where the area they live, they will see that as a star. You have to understand that also between 2 and 10% as non-good numbers yet do not see 3D whole their life. And most people never know. They especially have to do that. Okay? Because, why is that? Because we depend way more on one eye information than 2 eye information. Way more. And if you fully depend on it, you don't know that you're lacking the 2 eyes. Okay? That's why when you do AR and VR, if you don't have monocular input, it'll never work. Now, there's another aspect, how we build up our environment, the space. Anyone knows that? We have 2 eyes, we have 1 eye. Don't tell me we have 0 eyes. Okay. It's motion. It's the ability to move around. And I can build up. Since I have 1 eye, I just have my input. Oh, yes. Sorry. Maybe improve here. Okay. If I have 1 eye, I have just my input. But it can be wrong. Can I prove you? And you would look with 1 eye. The shadow is giving wrong information to you. Yeah? You would be, this is floating. No, it's a flag behind you. Okay? That's why motion is super important. Okay? Motion parallax. When I move around, closer objects I perceive to move faster than the objects in the back. And that's how I build up information. So, if you do AR, think about how I can place my objects in my scene to really fast when I start to move to build up the differences between those objects. But you can see there's an overlap. And overlap is also another molecular input we have. Okay? But how we can understand that space faster. And one of the early examples was this. Who has been there? What do you do there?
You go to the Vatican? Well, it's in the Vatican.
Oh, that's the Vatican.
Yeah.
What do you do there? Walk around. Oddly enough. But how is it achieved? It's early game design. When you do game design, you make a decision how to move my player through the game. It's the same here. Those elements are placed specifically there on the focus points. Because if you could stand there, you would build a very fast, symmetric environment and you understand the space. But because they're placed there, you never can stand on spots. So you try to move the player around to understand the space and build up. So we have to move around. No, moving around in VR and AR has been a huge problem for us. And moving around is very known. Like go to a church. You see the people walk from the beginning to the end. They don't open the door and just look. See it? They walk. It's called early walk architecture because you have to walk to the building to understand the space. Okay, so all that information of one eye, moving around, all those non-clear inputs, how can we use that now to create better architectural presence? Well, I would say go to the internet. But I want to warn you for that one. If you go to the internet and you start to type in beautiful spaces, beautiful environments, beautiful architecture. And especially when you go to the Parthenon or the Pantheon, you type in a lot, you're going to find a lot. But also you're going to find books from John Ruskin. Did anybody read those books? Okay. 7 Lamps of Architecture, also nicknamed 7 Lamps of Beauty, where he described what is an honest and beautiful building. But yeah, his friend, another guy, if you like to do, wrote pretty much the opposite sometimes. So it's not useful for me if I get conflicting information. I want more scientific information. And you start to dig in, look around, and you start to see something like Vitruvius. Anybody know Vitruvius? You all know it, I'm going to tell you. Vitruvius was one of the first architects who wrote amazing books. De Architectura. Only one survived, but anyway. It's where he starts to talk about proporzione, beautiful proportions that humans like. Okay. Now, one of those things that he drew was those creatures trying to understand the human shapes and the beauty of it and connect it. Well, they look pretty crappy because they look creepy. One famous guy, the only thing he did, he saw those drawings and he dropped the square down. That's it what he did. And everybody gives him the credit for it. What's his name? Leonardo da Vinci. See? He dropped the square. And everybody knows the painting. Ah, and what do you call that painting? Or drawing? The Vitruvius man. Ah, see, you all know him. So, but when you understand, see that piece of document, it's really difficult to see in reality. There's also carvings in there. And there he starts to talk and explain the proportions of a human body, that the head is 1/8 of the human body. Things like that. And how the arm has to be that length. That creates beauty. And nowadays in schools we teach that. Look at Carl's body, it's perfect. I never had somebody say, yes, true. Okay. But we learn in drawing course and that has to be the proportion and everything. You're going to see on the internet all those shapes, they say those are beautiful shapes. You see all those famous buildings, but it all comes from a rabbit. It's true.
Fibonacci.
Fibonacci.
Two rabbits.
Because Fibonacci was studying the reproduction of rabbits without any dying. It's Fibonacci sequence. Now what the heck is that all to do with architecture and beauty? Fibonacci is connected to the golden section. We can connect them, the algebra and the geometry, we can connect them in this drawing where we have the Fibonacci sequence. And this gives us what we call the golden rectangle. Okay. And in courses you learn, hey, it was used in all those buildings. Bari, Mona Lisa, Apple logo, Le Corbusier, the Nautilus shell, tons of books on it. Who says, and when you type in on the internet, what is beautiful for the Pantheon, first thing I can read is the golden ratio. I have one question for you. If everybody loves the golden ratio, everybody has the same rectangle they like. And everybody says, huh? scientific proof though.